Hi everyone, welcome to this new video. Today we are going to talk about defining search spaces using Hyperopt. I'm going to get started by defining what is a search space according to Hyperopt. Well, in Hyperopt, a space or a search space is a graph of stochastic functions. And those stochastic functions define the hyperparameters that we're going to find. Now, Hyperopt operates in this way because it needs to implement adaptive exploration strategies to find the best hyperparameters. Now, I will not dive into the algorithms, but I'm going to show you how to define those stochastic functions using the Python client, the Python library. So here I am sharing the Visual Studio Code environment, and here I have prepared the most common stochastic functions that we will see in the next videos. So notice here that I am importing HP, the module HP from Hyperopt and NumPy because I will need this later. And the first stochastic function is choice. Now choice is very easy to understand. It returns one of the options, which should be a list or a tuple. The elements of options can themselves be nested stochastic expressions. So for example, let's define this space. And here I am providing a label and the options. And the options is a list in this case, right? And as you can see here, this option is an stochastic function with more options. So let's print this space. And here we can see the graph. So basically this graph says to Hyperopt how to get a sample from this space. Let's get a sample using stochastic.sample. In this case, we get option 1, but let's say the option 1 again. Option 3, 2 now, this one, right? And so on. Let's move on to the next stochastic function, which is HP random, right? This is very easy as well. It returns a random integer in the range low and high. So for example, here I am defining low as 5 and high 10. Let's print a sample of this space. 9 makes sense. 6, yes, those values are between these values, 5 and 10. Let's move on to the next space, and you might want to use this for integers, right? Now this one uniform. Uniform returns a value uniformly distributed between low and high. So for example, let's say that I need a real number between 1 and 7. I can use this stochastic function. For example, this, right? I am getting, let's say, always a real number. Let's move on to the next function. In this case, it's called key Q uniform, right? And key uniform basically returns a value like this. So basically here we can see a new value called Q. Basically this stochastic function is limiting the output of this one uniform to multiples the Q, right? So for example, let's say that I want numbers between 0 and 100, but multiples of 20. Well, I can do something like this, right? Let me print this. That's okay. 20, perfect. 60, perfect. Let's say that I want multiples of 5. 80, makes sense. 10, makes sense. 95, makes sense. So let's move to the next function. And this is log uniform. This is like uniform, but it's applying this formula. Basically, it's getting the exponential of low and high. Now, when do we need something like this? Well, we need something like this when we want to find values in a logarithmic scale. For example, let's say that you are defining a learning rate. That's very common in machine learning. So usually the values that we want to get are like this, right? They are following a logarithmic scale, right? Something like this. So let's say that I want to define something like this using log uniform. Well, in that case, I have to define low as 0.001 and high equals to the logarithm log 1.0, right? Because as I mentioned before, this is a logarithmic scale, right? So let's get a sample from that. Okay, we get 0.0, 0.0.0. So as you can see, every time that I run the code, I got a new, let's say, well, this is not new, but the scale is changing, right? And this is very useful when we want to get values like this. Usually when we are working with learning rates, instead of having values like this, right? We want something more like this, right? In which the magnitude of the number changes. Well, that was everything for this video. In the next video, I'm going to start applying this knowledge using scikit-learn. Let's define some spaces, search spaces, using real hyperparameters from scikit-learn. So that was everything. Thanks for watching and see you in the next one.